Hey everyone, today we are going to start a two-part lesson on translating conic sections. We've looked at graphing the basics for parabolas, circles, ellipses, and hyperbolas, but we're going to see what happens now when the center or the vertex is not at 0, 0, and we're going to look at how to translate those. So we first looked at parabolas and circles, and with parabolas, we're not going to spend a whole lot of time working on those. But I think it is important to show you at least the formulas. Noticing that we have a vertex at HK, we would translate this. This is actually something you saw last semester in Unit 5, I believe it was. It is called vertex form. And so what we're going to see is that we can shift things to the left or to the right or up and down using this idea of the vertex being at HK. The center is one that we've already looked at, so I'm not going to really spend any time talking about that, but we already practiced translating that. All right, and then we get to ellipses, and with an ellipse, I only wrote the equation one time, x minus h squared plus y minus k squared, all over a squared and b squared. But the a squared and b squared, remember, could be translated or could be changed positions. Just depending on, there we go, that's better. Just depending on the equation. So I wrote it twice here, but I didn't write it twice here. Notice I should have changed this one right here. The center should be at HK. So we have a center HK, just like with the circle, we change both signs and we just shift it. All right, so then we have the hyperbolas. Now, with this one, the tricky thing is that the x and the y in this case are the things that change position, not the a and the b. So you have to be very careful that if it's y first and then x, that we say that you have to remember that this is shifting in the y direction, not the x direction. So it's the same premise as a circle. It's just a matter of applying it. So rather than talk in theory, I'm going to show you a few examples. So the first problem says to write an equation of an ellipse with center 1, -4, a horizontal major axis length of 10, and a minor axis of length 4. So there are a few different ways that you could start to approach this problem. For me, I think what's easiest is when I draw a picture. It helps me to kind of picture what I'm seeing. So I'm going to draw a little sketch over here. And my center is at 1, -4. So I'm at 1, -4. So it's like there. And then it says that it has a horizontal, first of all, I'm going to say an ellipse. I remember that difference is that it has a plus in the middle instead of a minus. But it has a horizontal major axis length of 10. So that means going in this direction, this line should have a length of 10. But how long do you think each piece is going to be? Each part here is going to be 5 because they have to be even on each side. They can't be different lengths. And so this is actually going to be our A value. So I'm going to make a note that with the horizontal major axis length of 10, that means that A equals 5. And again, that's just by taking half of 10. All right, so then it says it has a minor axis of length 4. So that would be going from this way, like vertical, and it's going to be 2 and 2. So I'm going to say that B equals 2. Well, now this, I'm going to label this as H and K, and I'm going to start putting together my equation. So I know that I need to start with x minus h, so I'm going to have x minus 1. And I don't want to forget to square it. That is very important. All over, we'll come back to the a squared, b squared, plus y minus k. In this case, since k is -4, I'm going to actually put plus 4, quantity squared, all over, and then equals 1. So I have to figure out which one is the a value going to go under. Is it going to go under x or under y? What do you think which one do you think it's going to go under? Because it is a horizontal major axis, it is going to go under the x. So I'm going to put 5, but I have to remember to square it, so it's going to become 25. The y is vertical, so it's going like this, and it's going to be 2 squared, which is 4. And there you go. That's the whole equation. So let's look at another one. It's a similar type of problem. So I am going to have an ellipse, which means that there's going to be a plus sign in the middle. I have my h and my k values. Go ahead and tell me what your a and b values are. A is going to be half of the major axis length. So A is going to be 9, and then B is going to be 7. Next, I would like for you to tell me, when we start setting this up, how would we write our equation? Go ahead and set up the whole equation. So we're going to have x plus 5 squared all over, and then plus y minus 2 squared all over equals 1. So that's how I always start, and then I fill in my a and my b values. This time, it's a vertical major axis. So if I picture that it's going up and down like this, which means it's going to go under the y. So 9 squared gives me 81. And then the horizontal minor axis, 7 squared, gives me a 49. And so that should be your final answer. All right, let's go on to another example. Write an equation of a hyperbola with vertices 2, -1 and 2, 7, and with foci 2, 10 and 2, -4. So the instructions don't say anything about graphing, but I included a graph here because I think with this one, it's going to be even more helpful because we're not told what the center is. We know our vertices and we know our foci. From vertices, we can get our A value. From foci, we can get our C value. However, we need the center in order to find those A and C values. So let me graph these points. I've got 2, -1, and 2, 7. All right, for the foci, we have 2, 10 and 2, -4. So remember, A is the distance from the center to the vertex. So I want to start by finding the center. If I look for the center along this line, what is it going to be? It's going to be the midpoint between those 2 points. It needs to be equidistant between this point and this point. And in this case, that just so happens to be at the point 2, 3. All right, so my next step is to identify what is my A value. So A is going to be the distance. So I've got a distance from 3 to 7. So that means it's A equals 4. Then I can find my C value. And C value is going to be 4 plus another 3. So that's going to be a distance of 7. So C equals 7. All right, so we have our A value of 4, our C value of 7, and I can put that together to find the B value using the equation for foci of a hyperbola. So I'm going to have 4 squared plus B squared equals 7 squared. That's going to give me 16 plus B squared equals 49. I'm going to subtract 16, and that means that B squared would equal 33. Now, I could take the square root of that, but because the equation of a hyperbola is something over B squared, then I don't need to take the square root. I already know what B squared is. B squared equals 33. So let's start with this. I'm going to start with parentheses squared minus parentheses squared equals 1. At the very least, you can show me that. Like say, I know it's something squared minus something squared equals 1. You can even draw like the little fraction line if you want to show that you know it goes over something. Now, we need to consider which direction is this going to open. Since they're all lined up vertically, if I tried to draw this opening left and right, it wouldn't really make sense. That means it's got to open up and down. So that means that the y is going to go first. I'm going to have y minus my y value. So this is where a lot of mistakes are made. People will put y minus 2, but we have to put y minus the y value of the center. So y minus 3 minus, and then x minus the x value. All right, so a squared always goes first. So a squared would be 16. B squared would be 33. And there you have it. That's how this would look. That would be the equation of the hyperbola. So let's look at one more example that's similar to that one. Write an equation of a hyperbola with these vertices and these foci. So what I'd like you to do is first start by telling me, what would the center be? Because we have vertices at -1, 2 and 3, 2, I can find the midpoint and say that this right here is going to be the center. The center is going to be at the point 1, 2. Next, if I look at the foci, I'm at -3, 2 and 5, 2. What are the A and the C values? A is going to be the distance from the center to the vertex. So A is going to be 2. C is going to be the distance from the center to the foci. And so that is going to be 4. So C equals 4. So with that in mind, knowing now that A equals 2 and C equals 4, what is the value of B squared? I'm going to do 2 squared plus B squared equals 16. B squared equals 4. That should be a 4 then. So I'm going to get equals 12. So when I write my final equation, which is going to go first, x or y? Because it's lined up horizontally, it's going to open. Oh, sorry, I went through the foci, open like that. It's going to open to the left and to the right, which means that it needs to be x first. So I'm going to have x minus 1 squared minus, and then y minus 2 squared all over and equals 1. So in the denominator here, I'm going to have a squared, because again, a for a hyperbola always goes first. And then b squared we found was already 12. Be careful not to square that again and say that it'd be 144. That would actually be b to the 4th. So you just need to make sure that you're keeping it b squared and not squaring it a second time. All right, there you have it. That is writing the equations of ellipses and hyperbolas. And we'll continue this in the next tomorrow and continue looking at this and practicing with this. But in the meantime, let me know what questions or concerns you have.